like this? It's not clear. What do we need to do? First,
dy over dx.
very good. This is clear now. We're looking at a function y that is a function of x. This I don't like. How do I write this?
Five over y squared.
Excellent. Very good. Excellent. Cross multiply. Y squared dy equals 5 dx. Ready? Completely separated. Y on one side, x is on the other. It's all good. Nice. Good. Can anyone give us the left-hand side? You gave it to me before. Y cubed over 3. Can anyone give us the right-hand side?
5x plus c.
Very good. Awesome. Of course, we did this before. I have to multiply by 3. I'm going to write 3c because I have to use 2 when x is 2, y is 3. So 27 equals 30 plus 3c. Or we can still consider the c, it doesn't really matter. So I have negative 3 equals 3c, so c equals negative 1. Still, I will still get negative 3, it doesn't matter, as you see. So then y equals the cube root of 15x minus 3. And this is the unique solution. Of course, this is a function of x. So this is the only function that verifies this differential equation and has the initial condition. Y of 2 is 3. I think you were able to follow. I think that this was the most intense type of problem, if you want, or topic. From here on, the last chapter is easy, I think. Any questions on 41? Any questions? Okay, so let's finish up this chapter with a word problem. So let's take a look. The growth, what are they giving us here? Okay, so let's look at 47. I hope I have time to finish it. It's called capital expansion. So they're giving us di over dt equals hki. We'll see what that means. I is the initial investment, H is the investment productivity, it's a constant, H is the marginal productivity, it's also a constant, and T is the time. Okay, so let's copy that first. So di over dt, obviously I is a function of t, they're saying that H is a constant, K is a constant, and times I. I is the initial investment, they say. These are constants. Use separation of variables to solve the differential equation. Of course, they want us to find I of t. This is what they're asking us to find, solving the differential equation. Okay, so these are constants, don't bother with them. What do we have to do first?
Multiply by dt.
Very good. So that's the first step. So whatever hk times I times dt. Awesome. Again, these are just constants. Don't even look at them for now.
And then divide by I.
Of course. Thank you very much. Excellent. So di over I equals hk dt. Awesome. We're happy. This is a constant. I is alone on one side. T is alone on the other. We are ready to integrate. Okay, the book is always in the way. Okay. So the left-hand side will be
ln absolute value of I.
very good. So I need to plug in my laptop. The battery is running out. Okay, so very good, natural log of the investment. Since the investment cannot be a negative number, in this particular case we can omit the absolute value, but for now let's keep it. HK, which function prime is 1? Very good, plus a constant C. Okay, so in order to solve for I, we have I equals e to these. So I equals e to h, k, t, and the rule allows us to write e to a constant. So of course this is e of t.
Why
Yes?
not plus or minus this time?
Say that again. Because the investment cannot be negative. I can't say I invested negative $5,000.
Okay, yes, thank you.
Okay, rewrite the solution using k equals 0.4 and age equals 1.33 and an initial investment of, so when time equals 0, that's what initial investment means, I equals 500,000. So now for the second part, so this was part A. In part B, they say, rewrite the equation using k equals 0.4, age equals 1.33, and an initial investment of 500,000. Okay. So this is given to us in order to find this constant. And of course, they are giving us 0.4. They're giving us 1.33 to determine that particular situation. Okay, so we know that the initial is 500,000 equals e to 0.4 times 1.33, but times 0, so this will all be 1, multiplied by this constant, whatever this is. You can rename it as C or C1. This is not the same C, of course. This whole thing is C1. Okay, so then in this case, C equals 500,000. So this is I of t, which is 500,000 times E. I have to multiply these two. What do I get when I multiply those two? 0.4 times 1.33. I got 0.532 T. Any questions on this problem? This is how we use differential equations in solving real-life situations. Differential equations have multiple applications everywhere. In physics, in economics, in everything. Really everything. So this